So the final pathway we're going to consider today is the common pathway. After the extrinsic pathway has turned the key in the ignition and the intrinsic pathway has begun accelerating the process, both these pathways lead to the common factor 10. Now factor 10 is the start of the common pathway, and it, alongside factor 5, work together to activate factor 2. Factor 2 in the inactive form has a name, and it's called prothrombin. That's the only one we're going to consider today after factor 1. Factor 2, before it is activated, is prothrombin, and this becomes activated to thrombin. This in turn then activates factor 1, which in its unactive stage is called fibrinogen, and this becomes activated to form fibrin. Now factor 1 and factor 13 work together to finalize this stabilizing of fibrin by cross-linking it. Now to go through the two key players just in a tiny bit more detail, fibrin is obviously the most important factor in this pathway. It's the end point at which it all becomes cross-linked and plugs that clot to stop bleeding. Factor 2 is the next most important, as what it actually does is it works to accelerate the entire process and essentially activates factor 8A, factor 5 and factor 13, which feed back into this cascade in order to amplify the amount of fibrin that gets produced in a very short space of time, and that helps feed into this pathway in order to make sure that more fibrin is produced overall when bleeding occurs and when fibrin deposition is most needed.